this video, we are going to study instruction formats. A computer usually has a variety of instruction code formats. It is a function of the control unit within the CPU to interpret each instruction code and provide the necessary control functions needed to process the instruction. So CPU will interpret what the instruction code means, and then the control functions will act upon it. There are different fields in the instruction code. There are mainly three fields: the opcode field, the address field, and the mode field. Opcode field specifies the operation to be performed. Address field designates a memory address or a processor register. Mode field specifies which addressing mode has to be used and how the effective address is determined. Special fields in instruction codes. Other special fields may sometimes be employed under certain circumstances. For instance, a field that gives the number of shifts in a shift type instruction. We will see this later when we will study the shift instructions. In a computer where the CPU has 16 processor registers R0 to R15, the register address field would comprise of how many bits? So there are 16 processor registers, so these 16 processor registers will be denoted by 4 bits. So those 4 bits will be 0000 to 1111. So whole these 0 to 15 registers will be denoted by these 4 bits each. So if all the bits are 0, it means R0 is selected. If all bits are 1, means R15 is selected. So which register would the binary number 0101 designate? So 0101 corresponds to 5. So in a sequence from 0 to 15, 5 is the 6th register. Length of an instruction. So based on different organizations of the CPU, different sizes of instructions are there. In the single accumulator organization, all the operations are performed with an implied accumulator register. So addx means that we are adding mx value into the accumulator and the result is saved in the accumulator. So single accumulator organization means that accumulator will handle all the final values. So there will be only one address field. In the general register organization, there may be 2 or 3 registers. Add R1, R2, R3. So in R3, R1 plus R2 is sent. And same when we do add R1, R2 means R1 plus R2 is sent into R1. When there are 2 or 3 address fields, we know that it is general register organization instruction format. In the stack organization, there are 1 or 0 address fields. When it is 1, when there is a push or a pop. When there is a push X, so address X is pushed on the top of the stack. When there is instruction just add, we are writing just add. This means we want to add the top 2 elements of the stack. This add statement does not have any address field with it, so it is a 0 address field instruction. This push X has 1 address field, so this push X is 1 address field instruction. So let's evaluate the arithmetic statement x equal to a plus b into c plus d. We have these commands: load, store, add, subtract, multiply, divide. So using the 3 address instruction, we can have 2 or 3 registers. So now we want to evaluate this expression using 3 address instruction mode. 3 addresses means we have 3 addresses here, 1 from the register and 2 other from the memory. So here MA is holding the value at address A in the memory. So this is A, At this location, whatever the value will be, this is denoted by m of a. This is memory m. So this value, maybe it is 10, is added to m of b. So suppose this is b, 20. So 10 plus 20 is calculated and sent to R1. Similarly, C plus D is sent to R2. Now we want to multiply R1 and R2 and save the result in X. So M of X is saving the result of R1 multiply R2. So this is by using 3 address instruction. 1, 2, 3. What are the advantage? The resulting programs are short. Clearly, my program was only 3 lines. Disadvantage: binary coded instructions require too many bits to specify the address. Now using the to address instruction, so we have two addresses at one time. Move A into R1, add B into R1, then move C into R2, add D into R2. Now what is happening here? R1 is M of A and M of B effectively, and similarly here effectively what is happening? M of C plus M of D, which we saw earlier. Now when we want to multiply R1 and R2, so the result is saved in R1. So this means the multiplication is done and the result is saved into R1 itself. Then we move the final value of R1, which is having this value of R1 into R2, and we send it to M of X. At location X we send R1. So our purpose is solved. Using the one address instruction, we can have only one address at most. So load A, add B, store T. Every time you will see that accumulator is being used. So this is a single address instruction. Every time accumulator will be used. This is for sure. So load A, so it means load the value of A into accumulator. Add B means add the value of B into the accumulator. Store T means accumulator value has to be saved at location T. Load C, load the value of C into accumulator. Add D into the accumulator. Multiply T. Now we have to multiply the value at location T with the accumulator and save the final accumulator value at memory location X. So our purpose is solved using one address instruction. Zero address instruction, we have to use stack. For zero address, it is a rule that we have to use stack only, no other ways there. Push A, push B. So one address is allowed in case of push and pop, but in case we want to do add or multiply, no address has to be given. So push A, push B. So my stack will be A and B after these two statements. Then add means when add happens, my stack will be having A plus B. Push C, push D, again add. So when again add happens, what happens? A plus B, C plus D. Now multiply. When multiply comes up, we have to multiply. So A plus B into C plus D. So this is my top of the stack now. Now pop X, it means that I want to pop this value and save it at location X. So the top of the stack is sent into MX. Purpose is solved. To evaluate the arithmetic equation in the stack-based computers, it is necessary to first convert the expression into the reverse Polish notation. We have seen earlier how the reverse Polish notation is done. So what will be the reverse Polish notation of this one? It will be A, B plus, C, D plus, and multiply. Now how to solve this? A and B are pushed, plus comes up, A plus B is done, then C and D are pushed, then again plus comes up, A plus B, C plus D, then multiply comes up, the final answer is A plus B multiply C plus D. So I have just summarized how to evaluate the postfix expression.